if the sky is a sphere, where do we start measuring positions in the sky? Welcome back to Boring Astronomy. I'm Alessandro, your astronomer next door.
Boring Astronomy.
I'm Alessandro. I have been in astronomy for the past 20 years. I'm here to share with you some of the things that I've learned along the way. Imagine that you have a sphere, and for lack of anything better, I have a kiwi in my hand today. Yes, this is the closest thing to a sphere that I could find at home. Pretend this is spherical. If this was a sphere, looking at it from any position would be the same. So if I want to say that this position is different than this position, how do I do it? On Earth, we are lucky because Earth rotates, right? So since we know that the Earth rotates, there are 2 points which are special. Those are the poles. And if we have 2 special points, that is already something. Then again, we still don't know because all of these places around here, they're still identical. But at least we have one place which is very, very special, which is the place which is at the same distance from both poles, right? There's one line in the center here, which is at the same distance from the 2 poles. On Earth, we call that place the equator. We have the same thing in the sky, and we can look at this in the sky. Let's open Aladin and let's see. You can see a series of obvious things, but most importantly, I overlaid for you our coordinate system. And the only things I want to show you here is the 2 poles and this horizontal line, which is the equator. I can represent this in Python, and again, now I have this horizontal line. This is our celestial equator, how we call it. You may have noticed that in the sky there is something else which is very, very obvious, and is this thing here, which is the plane of the Milky Way. So if I ask Aladin to show me the sky in galactic coordinates, and we are going to make a video about galactic coordinates some other time, this is the sky in galactic coordinates. So I am actually using another plane to describe the sky. If this is our normal coordinate system, this is how the plane of the Milky Way looks in our funny coordinate system, right? If I now go back to Aladin, I'm trying to convince you that this is very much similar to what you just saw. It's actually flipped because of the way Python works. There is one third thing that I want to show you. And for this, I need to show you the constellations. Maybe I remove the grid to make it clearer. So you may or may not recognize a series of names. Aries, Taurus, Gemini, Cancer, Leo, Libra, Scorpio, Sagittarius, Aquarius, Pisces, and we're done. So this is, you probably guessed it, is the Zodiac, is the 12 signs of the horoscope. And why are these 12 signs so special? They're so special because it's the apparent movement of the sun across the year. So you probably know that if you are born in December, the Sun is in Sagittarius, roughly speaking. So if I go back here, if I try to see the position of the Sun along the year in the coordinate system that the astronomers use, this is how the Sun moves. This inclination is actually due to the inclination of the Earth axis with respect to the orbit around the Sun. So actually this is about 27 degrees if I'm not mistaken. And you can see that if this is the equator and this is the position of the Sun in the sky along the year, these two circles, they cross in 2 points. And I'm going to explain you this using my house keys and my wedding ring, if I manage to take it out. If they are on the same plane, they have a complete overlap, right? But if one is inclined with respect to the other, let me see if I manage. You can see that they actually cross in only 2 points, and you can make this experiment at home and you can actually visualize it. You just need 2 rings. And here the 2 points are 2 points which are very, very special. One point, this one, is the moment the Sun is perpendicular to the Earth equator in March, 21st of March, is the equinox of spring or autumn, depending on your hemisphere. And this other one, obviously, is the equinox of September. So this actually defines 2 important moments along the year that we can use as a reference in this horizontal circle, where otherwise all points would be identical. So we decided to pick the March equinox. It's an equinox, it's easy to measure, and that is the origin of the sky for us astronomers. Next time we're going to speak about how to identify an object in the sky using red ascension and declination. Incidentally, recently, Nora Bailey published a beautiful short about exactly this same topic on her YouTube channel. So if you don't follow her, go check her out. And if you like my content, well, click on like, subscribe, and see you the next time. Get bored. Ciao.